with the main with the topic that we are going to cover this hour. Okay, we're going to cover factoring, writing logarithmic equations into exponential equations, writing exponential equations into logarithmic equations, graphing exponential and logarithmic functions, expanding and condensing logarithms by using properties, solving exponential equations by using the same base rule, and solving exponential equations with different bases, and lastly, solving logarithmic equations by using logarithm properties. So to start off, let's start off with factoring. What's the purpose of factoring? The purpose of factoring quadratic expressions is to eventually lead to a method of solving a quadratic equation. This is a graph of a quadratic equation. These are called my zeros, or my solutions, or my x-intercepts, or my roots. These has 4 different names that they can that this can be called. Okay, for example, this graph, this is the equation for this graph. This is the quadratic equation, and this is how we find the zeros, which are the x-intercepts. This is what I'm going to show you in this part of this PowerPoint, how to factor. Okay, these are my solutions, -4 and 2. There's my -4 and there's my 2. Okay, now these are real life examples of quadratic equations or parabolas. You see, for example, the bridge, right, has like an arc, is like a quadratic equation, and that's my equation. These are also parabolas, right? So all these are examples, and this is a roller coaster. There's a whole bunch of parabolas here. The arcs of McDonald's. And these are actually from word problems in mathematics. This is a maximum, right? And also this is a maximum. This can, this is also a quadratic equation or quadratic function. And I believe last week is where we found the vertex of these quadratic equations. But for now, guys, I'm just showing you examples of quadratic equations. Okay, now these are the factoring steps, and this is a factor sheet. Okay, now I do not permit my students to use these on exams, but they can use these for their homework. And to me, guys, this is like a guide for students to follow. That way, they know exactly how to what are factors, and also how to what are the steps when you're factoring. Okay, so in my class, I hand out these handouts to the students, but I tell them that they cannot use them on the exams, but they can use them to help them do their homework. Okay, now these are the factoring steps. I'm going to be covering every step here, every single step I'm going to be covering. Okay, so to start off, let's start off with the vocabulary. Quadratic expression is an expression involving a square term. Examples: x squared minus x minus 12, x squared minus 4, negative x squared minus 4x minus 2. These are all examples of quadratic expressions because the highest power is 2. Factors. Factors are the numbers multiplied together to get another number. Example, what are the factors of 12? How can we get 12? 1 times 12, 2 times 6, 3 times 4. So the factors of 12 are 1, 2, 3, 4, 6, and 12. These are called factors. Example 2, what are the factors of 20? How can we get 20? In the same manner, 1 times 20, 2 times 10, and 4 times 5. So the factors of 20 are 1, 2, 4, 5, 10, and 20. If you notice, all these two factors to give me 20 is the first times the last, the second from the front times the second from the end, and so forth. These is how we get my 20. Greatest common factor, the GCF. The GCF of a set of numbers is the largest factor that all numbers share. Example, what's the GCF of 12 and 20? For example, the factors of 12, right, we just got them earlier, which are 1, 2, 3, 4, 6, 12, right, which was from example 1. And the factors of 20 were from example 2, which is 1, 2, 4, 5, 10, and 20. So what are all the numbers that they have in common or that they share? They have 1 in common, they have 2, they have 4. But what's the highest one or the greatest one? The answer is 4. That's what they mean by the greatest common factor. So the GCF of 12 and 20 is 4. Okay, now, at times students have been out of school for a long time, right? And they don't know what other factors are. That's why I let my students use this handout, because this way nobody gets left behind. For example, how to use this handout to get the factors of 12 and 20. I'm going to show you. Okay. Again, this is example 1, right? These are the factors for 12. That was the factors of 20. And the GCF was 4, right? So this is how you use the factor sheet. How does the factor sheet work? Factors of 12, right? We're going to go to 12 here on the sheet, right? So it's there. Factors of 12. So factors of 12, right? I enlarge the square, which is going to be, right? And then we get the factors of 20. We go to 20 here on the factor sheet. So it's going to be, right? So what's the biggest factor they have in common? The answer is 4. So this is for no student for them to get it behind, because like I said earlier, some students don't know how to find factors. So this handout will give them a hint on how to find the factors, but it's best for them to know how to do it without this handout. Okay. So the answer was 4. Okay, now this is the factoring steps. These are the steps that I came up with. This is like a roadmap on how to factor, because at times students say, Mr. Sassi, well, when do I stop? When none of these can be applied. Okay, after you've done none of these and nothing else can be applied, that's when you stop. Okay, so for example, this is step number 1, right? Step 1, the GCF, which means what's the greatest factor to factor out. Okay, so that's step 1 here. So again, what's the GCF of 20 and 30? Right, we're going to get the factors of 20 and the factors of 30. How can we get 20? 1 times 20, 2 times 10, 4 times 5, and that's it, because once after they repeat, because the next one will be 5 times 4. Once they repeat, you stop there. So these are the factors of 20. How about 30? 1 times 30, 2 times 15, 3 times 10, and 5 times 6. So those are the factors of 30. Okay, now what's the numbers that they have in common? They have 1 and 2 and 10. What's the greatest one? The GCF is 10. That's how you find the factors of any number. Okay, now, how about the variables? What is the GCF of x squared and x cubed? X squared is the same thing as x times x, and x cubed will be the same thing as x times x times x. So the GCF is x squared, because they have 2 x's in common, right? They have 1 here, then they have another one, so they have 2 in common, and x times x will give you x squared. Anyway, guys, this is an observation. If both terms have the same variable or the same letter, right? The variable with the smallest degree is a GCF. For example, this has an x, but that has an x, right? So what's smaller, the x squared or the x cubed? The x squared. So the x squared will always be your, the smallest degree will always be your GCF. Okay, now, let's put them together now. Factor out the GCF. You have 30x squared plus 20x cubed. Between the numbers, right? Then we do it earlier, 20 and 30. Wasn't it 10? Now for the variables, wasn't it x squared? So this is my GCF of these two terms, 10x squared. So I'm going to factor it out, right? If I factor out that 10x squared from 30 and 20, right? From 30x squared and 20x cubed, what's left here? Here you can do it 2 ways. You can do it by multiplying or by dividing. I like to say, I like to use multiplication. For example, 10 times what number will give me 30? So the answer is 3. We have x squared, right? And we need x squared. Do we need more x's? No. So we're okay here. The sign comes down. What number times 10 will give me 20? The answer is 2. We have x squared. We need x cubed, right? So we're going to need 1 more x. We close our parentheses. So this is how you factor out the GCF. Okay? Factor out the GCF continues. Now we have x times 2x minus 5 plus 2 times 2x minus 5. If you notice, This, in parentheses, is called a binomial. So they both have the binomial in common, the 2x minus 5. So the GCF will be 2x minus 5. Right? So they have that in common. So if you factor out the 2x minus 5, right? If you take it out, if you factor it out, what's left? X plus 2 is left. So for the factor, to factor out to factor out from this problem here, the x over 2x minus 5 plus 2x minus 5, right? The answer will be 2x minus 5 and x plus 2. This is how you factor out the GCF. This example is crucial for factoring polynomials with 4 terms, which I'm going to show you later on this PowerPoint. Okay, now, here we go. If you have 4 terms, you're going to factor by grouping. For example, this is an example from the book. You have 2x squared plus 8x plus 3x plus 12. By grouping means you're going to put them in pairs. You're going to group the first 2 terms, and the second 2 terms, which is group 2. Okay, for group 1, what do they have in common between 8, right? The 2 is 1 times 2, and the 8 is 1, 2, 4, and 8. These are the factors of 8. So what they have in common are the 1s and the 2s, right? So the GCF will be 2, because that's the highest factor between 2 and 8. And for the variables, right, they both have an x. So the one with the lowest, the smallest degree will be your GCF. So the GCF is x. So the GCF of 2x squared plus 8x is going to be 2x. Right? So let's put the 2x there. So if I factor out the 2x, right, we'll be left with x plus 4. Why? Because 2x times x will give me 2x squared, and 2x times 4 will give me 8x. Now we do group 2. We've done the sign, and we do group 2 now. So group 2 just put here on the right. So between 3 and 12, right? Between 3 and 12, the greatest factor is 3. And between the variables, the 3x has an x, but the 12 doesn't have an x. So this is the only GCF will be 3. So the GCF of 3x plus 12 will just be 3. So I'm going to factor out the 3. So what's left? X plus 4. Because 3 times x will give you 3x, and 3 times 4 will give you 12. If you notice, they have the same binomial on both terms. So that's what they have in common, will be the x plus 4. So what's left? 2x plus 3 is left. So this is my solution, right? Or this is what I'm looking for. So if you factor 2x squared plus 8x plus 3x plus 12, if you factor it, it's going to be x plus 4 and 2x plus 3. Okay, now, this is what I'm talking about, right? It's going to be here 2c, right? So the step 2 is determine the number of terms. That's step 2. If you have 2 terms, then it's going to be either perfect squares or perfect cubes. If you have 3 terms, it's going to be the easy factoring, which I call easy factoring, or by grouping. And then 2c if it's 4 terms. So this is what we're doing now, is a 2c. Okay, now, factor by grouping. I have a different way of factoring by grouping than what the book does. Example 4 was from the textbook, but this is the way I show my students. Okay, if 4 terms is going to be 2c, right, it's going to be factored by grouping. Example. I factor by grouping, right? So to find the GCF of the first 2 terms. So between 2x squared and minus 5x, the GCF will just be x. Right, so I'm going to factor out the x. So what's left is going to be 2x minus 5. Again, because x times 2x will give you 2x squared, and x times negative 5 will give you negative 5x. Okay, now this is what I do. What was left, I also put it on the right side. The sign comes down. Now you can ask yourself, what number times 2? What number times 2x will give me 4x? So the answer is 2. Because 2 times 2x will give me 4x, and 2 times negative 5 will give us negative 10. You see, because my method is, I believe it's quicker and it's simpler. Okay, but it's up to the student to decide that. But in my opinion, it's easier to do it this way. Okay, now, students might ask me, Mr. Isasi, will it always work? Yes, if you can factor by grouping, what you factor out here, I mean, what was left after you factor out the x will always be on the right side also. So the GCF will be 2x minus 5. So if I factor out 2x minus 5, what's left? The x plus 2. So this is how you factor by grouping. Okay, I put here on the bottom. I modified a little from the textbook. The binomial that is left after factor on the GCF on the first two terms will always be the same binomial on the left, on the right side, if it can be factored by grouping. This is what I mentioned earlier. What was left right after you factor out the GCF, which was x, you'll always put it also on the right, because this will always be true if it can be factored by grouping. Okay, now we're going to be doing step number 2, all right? So if it happens to be two terms, right, it can be perfect squares or perfect cubes. So let me first do the perfect squares. Okay, now, right, so I'm writing what's here and here, guys, right? So if it's x squared minus y squared, it's going to be x minus y and x plus y. If it's a plus, it's going to be a prime, which means it cannot be factored. So if it's plus, it's going to be a prime. Okay, now, this is more examples here. So this is step number 2, right? Determine the number of terms. I put here, notice. Note, make sure that terms are in order. If not, rewrite in order from highest degree to smallest degree before continuing. So 2 terms, right? We're doing the perfect squares. Okay, what does it mean by perfect squares? These are perfect squares. For example, x to the 4th is a perfect square. Why? Because x squared times x squared will give me x to the 4th. X squared is a perfect square because x times x will give me x squared. 1 is a perfect square because 1 times 1 will give me 1. And so forth, right? So these are the perfect squares or perfect square numbers. So example 6. X squared minus 1, right, is going to be x minus 1 and x plus 1. X squared minus 4 will be x minus 2 and x plus 2. X squared minus 9 will be x minus 3 and x plus 3. What would that one be? Can somebody put in the chat? What would that one be? X squared minus 49? Anybody? So this will be x minus 7 and x plus 7. X squared minus 81 is going to give us, right, x minus 9 or x plus 9. X minus, I mean, here, guys, I changed the order around because at times students think that the first has to be negative. No, guys, this is, you have to have the same, the x and the 9, right, but one's positive or one's negative. It doesn't matter what's first, the positive or the negative. So x squared minus 100 is going to be x minus 10 and x plus 10. 25x squared minus 36y squared. You see 25 is a perfect square, right? It's going to be 5. And 36 a perfect square is going to be 6. And also x squared and y squared are perfect squares. So this will be 5x minus 6 and 5x plus 6. How about x squared plus 36? This will be prime. Why? Because if it's plus, it's going to be prime. So please be aware of that. That's why these are called the difference of two perfect squares. There's no such thing as a sum of two perfect squares, because there's no such thing because this cannot be factored. If it's plus between two perfect squares, it cannot be factored. That's why it's called prime. Let's do one more example. X to the 4th minus 16 will give us x squared minus 4 and x squared plus 4. X squared minus 4 can still be factored, right? But x squared plus 4 is prime, but this x squared minus 4 is not prime. This can be x minus 2 and x plus 2. And the x squared plus 4, we just bring it down. So these are the factors of x to the 4th minus 16. Okay, now let's do perfect cubes, right? So we're doing this one here. Example number 2A, which would be number 2 there. Okay, now these are perfect cubes here, guys. These are the formulas. This is called the difference because the first one's minus. This is called the sum of two perfect cubes. These are perfect cubes. X to the 6. Why? Because x squared times x squared times x squared will give you x to the 6. X cubes are perfect cube because x times x times x will give you x cubed. 1's a perfect cube because 1 times 1 times 1 will give you 1 cube. And what it means here, guys, by perfect cubes means one number multiplied by itself 3 times will give you 8. And the answer is 2. One number multiplied by itself 3 times will give you 27. The answer is 3. And so forth. Okay, now, example number 7. X to the third plus 125. We know that x cubed is a perfect cube. 125 is also a perfect cube. It's here, right? 125 is 5 cubed. So let me rewrite it, right? So it's going to be the sum, right? Let me rewrite it. There's my formula. Now let me rewrite the x cubed plus 125 in terms of cubes. This is the same thing as x cubed plus 5 cubed. Here's how we do it. That's going to be my x. We're going to let x equals to x and y equals to 5. So everywhere we see an x, I'm going to put an x. Everywhere we see a y, we're going to put a 5. Right? So x is going to be x. Y is going to be 5, right? X squared will just give us x squared. X times y is going to be the same thing as 5 times x. And y squared will be 5 squared. Now let's rewrite it. It's going to give us x plus 5 times x squared minus 5x, because 5 squared is 25. That's what will be plus 25. So this is how you factor x cubed plus 125. And that was the one. Now let's do another example. Hey guys, I'm doing only one example of each because of lack of time. Because I still have a lot of material to cover. Okay, now we'll be doing if 3 terms, right? If 3 terms, let's do the first one first, which is called the easy factoring. If it can be factored, right, all we do is put 2 parentheses, and I'm going to tell you what to put inside the parentheses. This is called the easy factoring, right? So now, the c is called the constant term, and this is called the bx term. So if the constant term, right, if c is positive, the signs in the binomial are going to be the same signs. And in this case, they're going to be positive. If the constant term is negative, we're going to have different signs here in the binomial. And it's going to be different subtraction. Okay, now, are the signs the same or different? Okay, for these, I'm going to ask the students if the signs are the same or different for the following examples. Since I don't have access to the chat right now because I'm sharing my PowerPoint, I'm just gonna do these for you guys. Okay, I'm gonna show you how to do them. Example number 8: x squared minus 10x plus 24. Are the signs the same or different? Right. So this determines if the signs are going to be the same or different. If it's positive, they're going to be the same. If the last term, the constant term is negative, they're going to be different signs. So in this case, they're going to be the same. Example 9, right? The constant term is negative, so they're going to be different. Number 10, negative, right? It's going to be different. Number 11, the constant term is positive, so that's going to be the same. Now I'm going to factor out these 4 problems on the next slide. Okay? The sum, okay, this means also the sum. The same means the sum of the factors must equal to the bx term. This will be the difference. This will be also the difference of the factors must equal to the bx term, and this will be the sum. Okay, now I'm going to factor those 4 examples here. I'm going to do one in each slide. So example number 8. Okay, we know that the signs are going to be the same, right? So this sign, you always bring it down. And they're both going to be the same, right? So they're both going to be minus. Okay, now we're going to get the factors of 24. How can we get 24? 1 times 24. I mean, this is negative, right? Because this is negative. What 2 factors will give me 24? So negative 1 times negative 24. Negative 2 times negative 12. Negative 3 times negative 8. Negative 4 times negative 6. And then when you add them, right, it must give you negative 10. So what's negative 1 plus negative 24 will give us negative 25. Negative 2 plus negative 12 will give us negative 14. Negative 3 plus negative 8 will give us negative 11. And this is to find the bx term. Negative 4 plus negative 6 will give us negative 10. So here's my combination. Negative 4 and negative 6. So this is my solution. This is the x squared minus 10x plus 24. These are the factors. And now let's do another example. Example number 9. You see the signs are going to be different, right? So we bring down the sign. So it's going to be a minus and a plus. Why? Because the signs are going to be different. Because this is negative. Okay, now can I get negative 30? Negative 1 times 30. 1 times negative 30, right? Negative 2 times 15. 2 times negative 15. Negative 3 times 10. 3 times negative 10. Negative 5 times 6. And 5 times negative 6. So the subtraction, right? The difference has to give me negative 7. This will be positive 29. Negative 29. Positive 13. Negative 13. Negative 3 plus 10. This will give me 7. And negative 7. This will give me 1. And negative 1. So which one is my combination that I'm going to be using? It's going to be this one here. This is my match. Negative 10 and 3. Because negative 10 plus 3 will give us negative 7, which matches my bx term. So the answer will be x minus 10 and x plus 3. This is example number 3. Okay. Again, this is negative, right? So there were different signs. So it's going to be a positive and a negative. Now, factors of negative 20. We're going to get negative 1 times 20 and 1 times negative 20. Negative 2 times 10 and 2 times negative 10. Negative 4 times 5 and 4 times negative 5. Now, what goes here, guys, will be the difference. Difference of two factors equal to bx term. So this will give me 19. Negative 19. This will give me 8. Negative 8. This will give me 1 and negative 1. So what's my match? My match is 1, right? So my match will be negative 4 and 5. Because negative 4 plus 5 will give me 1, which will be 1x. So then this is my factor form. X plus 5 and x minus 4. Because the 5 is positive and the 4 is negative. Okay, now example number 11. This will be the last example on factoring in this form. So the signs are going to be the same, right? So we'll be on the sign here. So it's positive. So they're both going to be positive. Okay, now factors. Hey guys, this will be a 15 here, guys. I think I changed it. This should be a 15. So factors of 15 will give you 1 times 15. And again, guys, this is my mistake here. This should have been a 15. 3 times 5. So it's going to be the sum. The sum must give you 8. Right? Which one is it? This will be 16. This will give us 8. So these are the factors, the 3 and the 5. So x plus 5 and x plus 3. Okay, now we're doing the last part here for the factoring, right? When it's 4 terms by grouping, right? What's the difference between these two, between the 3 terms and 1 and 2? This one, the coefficient here, guys, is always 1. And here is going to be something besides 1. That's why this form we do it by grouping, which is this one here. And here in the handout, it tells you exactly what to do, which I'm going to show you right now. Okay, I got this from the handout. So the first thing that you guys do is you're going to multiply the A coefficient and the C coefficient. Okay, here we go. So let's start it off. So 3 times 10 is 30. Now we get the factors of 30. How can we get 30? 1 times 30, 2 times 15, 3 times 10, and 5 times 6. And this means, right, that we're going to add them. At the factors to get the bx squared. And we want to get 11x here. So 1 plus 30 is 31. 2 plus 15 is 17. 3 plus 10 is 13. And 5 plus 6 is 11. So this is my match. Positive 6x plus 5x will give us negative 11x. So these are my match. Right? So I'm going to plug that in for the 11x. If you notice, guys, here it also tells you what to do, right? It has 3, 4, 2 factored. At times 3 and what does that mean? It means that you start with 3 terms. Then the next row must be 4 terms. And then comes 2 terms, and then it's factored. So here, guys, so let's do what we did earlier. Between the first 2 terms, what do they have in common? All right, a 3x, because 3x squared and 6x have a 3x in common. So what's left here on the first term is going to be x plus 2. What you put in this side, right, you also put in the other side. I mean, on the right side. So then the sign comes down. 1 number times x will give me 5x. The answer is 5. Because 5 times x will give us 5x. 5 times 2 will give us 10. We can always check the previous step to see if we're in the right track. Now, what do they both have in common? The x plus 2. What's left? The 3x plus 5. So now it's factored. So these are the factors of 3x squared plus 11x plus 10. Example number 13. Right? So similar way, because this is not a 1, so we're going to multiply the 2 and the 9. Which will give us negative 18. So how can I get negative 18? Factor the negative 18. Negative 1 times 18. 1 times negative 18. Negative 2 times 9. 2 times negative 9. Negative 3 times 6. And 3 times negative 6. So these are the factors of negative 18. This means, right, there's going to be the difference. So the difference of the factors has to give me negative 3x. This will be, what, 17, negative 17, 7, negative 7. This will give us, what, 3, and negative 3. So where's my match? The match will be the, right, because this is negative 3, so this is my match here. So negative 6x plus 3x gives me my negative 3x. So I'm going to replace the 3x with negative 6x plus 3x. Will replace my negative 3x. If you notice, guys, this does not change the original expression, right? Because it's the same thing. There's my 2x squared. There's my negative 9. And negative 6x plus 3x gives me my middle term, which is a negative 3x. Now we do it by grouping. Right now we're going to go to 2 terms by grouping. They have in common, the first 2 terms have in common a 2x. If you factor it out, it will be left x minus 3. So just put it on the left side. So x minus 3 will bring down the plus. 1 number times x will give me 3x. So the answer here will be 3. So now they both have in common the x minus 3. So what's left? The 2x plus 3 is left. So these are the factors of 2x squared minus 3x minus 9. Okay, now we're done with the factoring, guys. And I know that I went in a little bit quick because I want to make sure that I cover the material for this week. Okay, now writing exponential equations into logarithmic equations and vice versa. So definition of logarithms to the base a. If you have y equals to log base a x means a to the y equals x. This is called logarithmic form. This is called exponential form. So here they want you to go from exponential to logarithmic. Example 14. Write each logarithmic equation into an exponential equation. So they give us log of base 9 of 81 equals 2. So what do? Right, so we're going to have to find what's a, x, and y. right? So we want to go from logarithmic to exponential, right? So I need to find the a, x, and y. If you notice, guys, the a going to be 9, the x going to be 81, and the y will give us 2, which means now I go here to the right. So right is going to be a, which is 9, y is 2, and x is 81. You'll see there's my a, there's my y, and there's my x. So this is how you write log of base 9, 81 equals 2 into an equivalent expression, but in exponential equation, which will be 9 squared equals to 81. So this is what they're looking for. Now you're going to go the other way, right? They're going to give you the exponential equation. You have to put it into logarithmic equation. So again, we need to go from a, y equals x, y equals to log of base a of x. So we have to know what the a, the x, and the y are. My a is 5, my y is 3, and my x is 125. So let's go back over here. So y is 3, right? So it's going to give us 3 equals to log. My a is 5, so that's why it's 5 there, the little base. And my x is 125, right? Or we can go from here to here. This is the same thing. At times, I believe the book has it, and back at the solutions, they have it in this form, but these are the same thing, guys, means the same thing. Okay? I want to give you 2 examples. I believe from these 2 examples, you can be able to follow these. Okay? Now, we're going to be graphing exponential functions and logarithmic functions. In order to graph without a calculator, must convert logarithmic equations to an exponential equation. So this, to graph logarithmic equations, we have to convert it to exponential first, all right? So I'm going to show you an example, I believe, in about 2 slides. So the first one is we're gonna graph exponential functions. These are examples of exponential functions. If you notice, the exponent is always an x. See? These are called exponential functions. Now recall from, this is something that I believe your instructor should have gone over already, but since this is a mini master, I usually cover this in a previous PowerPoint or previous workshop. But anyway, guys, this is the same thing as f of x. I mean, this will be similar to f of x equals to a to the x. The m over n, right, means that's your x, which means the x can be an integer or a fraction. A is a base. The exponent is a variable, right? The exponent, which is the x, is called a variable, which is a letter. Guess where it comes with that? Okay, now, if a is more than 0, that means that we're going to graph this function here, right? So these are the values that I'm going to plug in for x. Okay, because to graph an exponential equation or function, you usually use negative. These are the values that you usually use. These are the most common values used. So let's draw ourselves a little table, right? We have -2. So when x is -2, right? So I'm going to evaluate f of -2, which means I'm going to plug in -2 where the x is. This will give you 1 over 2 squared, which will be 1/4. So when x is -2, y is 1/4. When x is -1, right, I'm going to plug in -1 to the original exponential equation. So 2 to a -1 will be 1 over 2 to the first power, which will give us 1/2. So when x is -1, y is 1/2. Now let's try the 0. So when x is 0, we're going to evaluate f of 0. F of 0 means it's going to be 2 to the 0 power is going to be 1, because anything to the 0 power is 1. So when x is 0, y is 1. Now let's evaluate when x equals to 1. So we're going to plug in the 1 where the x is, right, where the exponent is. So 2 to the first power will just give us 2. So when x is 1, y is 2. Now let's try 2 for x. So let's evaluate f of 2, right? Which means, again, that I'm going to plug in 2 for the x's. So that's why we got 2 squared, which will give us 4. So when x is 2, y is 4. And finally, let's evaluate when x equals to 3. When x equals 3, right, it's going to be 2 cubed, which will give us 8, because 2 times 2 times 2, 3 times will give us 8. So that's when x is 3, y is 8. And here's the actual graph. If you notice, when it's negative 2, right? When it's negative 2, it means that that I'm going to cut between 0 and 1. I'm going to cut it into 4 parts, right? So when x is negative 2, it's going to be about right there. Right here, right in 4 parts. When it's negative 1, it's going to be 1/2. When it's 0, it's going to be 1. When it's 1, it's going to be 2. When it's 2, it's going to give us 4. Right there. And when it's 3, it's going to give us 8, right? When it's 3, it's going to give us 8 all the way up here. So this is the graph for the exponential function f of x equals to 2x. This is my graph. Now let's graph a logarithmic function. So before we graph the logarithmic function, we have to convert it into an exponential function. So y equals to log of base a of x equals to a to the y equals x. Example number 18, y equals to log of base 2 of x. So this is the same thing as 2 to the y equals x, right? And again, this this conversion, I did it earlier, I believe in 3 or 4 slides away. So we first have to convert it to exponential. Okay, now we're going to draw ourselves a little table. But instead of plugging in the values for x, we're going to plug it in for y, right? Because it'll be easier to plug them in for y. So if we plug in negative 2 for y, this is what it should give us. If I plug in negative 1 for y, it should give us 1/2. If I plug in 0 for y, it should give us 1, and so forth. So this is a graph. The one in blue is the one that we graphed earlier on the previous slide, and the one in red is a graph for the logarithmic. If you notice, when x is 1/4, right, 1/4 will be about right here, because 1/4 for the x means that I'm going to cut this one unit into 4 parts. You see right there, you can see the half. So 1/4 will be about right there where my arrow is. And it's negative 2, right? If you go all the way down, it's going to give us negative 2. And when x is 1/2, right, 1/2 will be about here. Y will be negative 1, and so forth. So this is the graph in red of the logarithmic function, and the one in blue is the one for the exponential function. And again, I only did 2 examples, one of each, because time is short. Okay, and the one in red is a log. So here we're going to expand or condense logarithmic expressions. These are the properties that students must know. This is called the product property, the quotient property, and the power property. And they also work also for the natural log, right? The ln, right? This is the product, the quotient, and the power. If you notice, right, if it's the product, right, the product property, it means you're going to separate them in two terms, the log in 2 terms, right, with x and y. So we're going to go in back and forth. We're going to be going from, this is called condensed, this is called expanded. So write each expression as a sum or difference with the variables to the first degree. So here, guys, I want you to expand it. Okay, now, which properties are present? If you notice, right, here's multiplication, and we have an exponent. So I believe property, the product and the power. So now we need to add 3 separate terms, right? Because it's 5 times x times y. So we're going to have three separate terms for the logs. So it's going to be log, right? And also my base, right? If there's no base, it's going to be base 10. So if there's no base, just don't put no base, but we know it's base 10. So log of 5 plus log of x to the fourth plus log of y to the third. Now we have to apply the power property, right? Because the exponent, right? The exponent must go to the front. Boom, you see they go to the front. So the 4 must go to the front. So this is this is the expanded version of log of base 10 of 5x to the fourth y cubed. This is the expanded version. Oh, I forgot about the 3. The 3 goes to the front. Okay, now, properties of logarithms. Again, these are the same properties as before. So now we wanna go back, right? We wanna expand them now. Now we're gonna expand it. So again, what properties are present? All properties, right? This is a product, the quotient, and the power. They're all there. So let's start off, right, with the product, right? I mean the quotient first. So it's going to be log x of y squared minus log of w. Now let's apply the product property, right? Because the log of w is okay, but this one we have to expand it. It's going to be log of x plus log of y squared minus log of w. And these are all base 10. Now we must execute the power property because the exponents must go to the front. So the 2 goes to the front. So this is the expanded version. So this is what we're looking for. Now we're going to condense them. Okay, again, same properties. We can write it as a single log. If we notice, right, subtraction, so we know that's going to be the quotient. The power, right, and the quotient, this is a quotient and the power because you notice if it's a number in front, we're going to be the power rule because the exponent must go to the front. I mean, must go to the top. The number in front must go to the top as an exponent. You see, as I did here. So execute the property coefficient in front becomes the exponent. So this goes to the front, to the top, the 2. Okay. Minus the ln of x plus 7. Then we apply the quotient property. Right, so subtract means quotient. So it'll be the ln of x plus 7 squared over x plus 3. So this is what we're looking for. Okay. Now we're going to be solving exponential equations. So you have to know the perfect squares, right? So these are perfect squares because 2 squared will be 4. These are called perfect squares here, guys. 3 squared is 9, 4 squared is 16, and so forth. So you have to know these, okay? You also have to know perfect cubes. Or because 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, and 6 cubed is 216. And for the fourth roots, you have to know, right? So 2 to the fourth power. Oh, this is this is, I mean, for example, these are roots here. If you have the square root of, the fourth root of 16 is going to give us 2 to the fourth power. So you have to know these right here, guys, right? That 2 to the fourth power is 16, 3 to the fourth power is 81, and so forth. You also have to know the exponential expression, right? So A is called the base, and M is the exponent. So you also have to know the exponent power rule. If you have a power raised to a power, you multiply the powers. And also you have to know how to solve one variable equations like something in this one. So you have to know all these to be able to solve exponential equations. Okay, now this is a rule here. Let A be a positive real number with A cannot equal to 1. So if A to the U equals A to the V, then U must equal V. In other words, if you have the same base, the exponents must equal to each other. Okay, example 22, right? We have the same base, right? Same base, so we can apply the rule. So X must equal to 5. That's your answer, that's the solution. Example 23, if you have a to the x equals to 2 to the 5 power, right, and we notice the bases are not the same. So we have to get them with the same base. So I know that 8 is the same thing as 2 cubed. So I'm going to replace 2 cubed for the 8. Right? Now we're going to execute the power property. I mean, or the exponent power rule. Here, guys, right, when we have the exponent power rule, it means that we're going to multiply the powers. So 3 times x will give us 3x. So when we have the same base, right, we get the same base, so then we can apply the rule now. So 3x must equal to 5. And then we solve for x. So divide both sides by 3, so x equals to 5 over 3. Hey guys, we can always check our work, right? We can always check our work. How do we check it? I'm going to plug in 5 over 3 for the x's. Right, let's see if it's true. So we can plug into the calculator, or we can do it without the calculator. Let's do it without. This would give you with the calculator. Let's get this without. We have to apply the fractional exponent rule. If you have a to the power of m divided by n, right? The exponent is a fraction. The denominator becomes your index. The a becomes your radicand, and the m, which is the numerator, becomes your exponent. And also this is equal to this. These two are equivalent. In my opinion, I like to use this one better. The parentheses, the nth root of a, close parentheses to the nth power is equal to a to the m over n. We have 8 to the 5/3, right? So again, the 3 is the index, the 8 is the radicand, and the 5 is the exponent. So what's the cube root of 8? It's going to give us 2, right? This is equal to 2. 2 to the 5th power will give us 32. This is how most instructors want you to do it, right? If you're taking, say, 0302, you cannot use a calculator, so this is what you got to use. Also, guys, this is crucial for students going like for math and engineering because they have to know how to convert something like a to the 5/3, right? How to get the answer without using a calculator. So it's good to know this rule here. Now, we continue. Example 24. We have 9 to the x equals 27. So again, right, these are not the same base. So we have to get the same base. Let's see if 9 to the second power will give me 27, right? It doesn't because 9 squared is 81. It does not equal 27. So that means that we have to find the same base between 9 and 81. Right, so the common base will give us 3. 3 squared, and 27 will give us 3 cubed. So I'm going to replace the 9 with 3 squared. I'm going to replace the 27 with 3 cubed. Now I'm going to apply the exponent property, the exponent power rule, which means when you have a power to a power, you multiply the power. So 2 times x will give you 2x. And the 3 to the third power will just bring it down. You see, now they have the same base. Now we can apply the rule, which means when you have the same base, you let the exponents equal to each other. Now we divide both sides by 2. So it's going to give us x equals to 3 over 2. And again, let's always check our work. If you plug in 3 halves for the x, 9 to the 3 halves will give us 27. So I know this is a solution. Okay. Solving exponential equations continues. Now this one's a little bit more challenging here. Example number 25. If you have 4 to the power of x minus 1 equals 32, right? We know that 4 squared, these are not the same base, right? Not the same base. So 4 squared is 16, right? It's not 32. Let's try 4 cubed. 4 cubed is 64, not 32. That means that I have to find the same base between 4 and 32, which means there has to be a smaller base for 4 and 32 that they can share. So 4 is equal to 4 squared, and 32 is equal to 2 to the 5th power. You see, now we have the same base. So we're going to replace 2 squared for the 4 We bring down the x minus 1. We're going to replace 2 to the 5th power for the 32. Now here we're going to apply the exponent power property, which means, right, we multiply them. So then it's going to be 2, right? We're going to multiply the 2 times the x minus 1 equals to 2 to the 5th power. You see now, guys, we have the same base. So we let the exponents equal to each other. Apply the rule. So now we distribute. So 2 times x will give us 2x minus 2 equals 5. We add 2 to both sides. So 2x equals to 7. We divide both sides by 2. So x equals to 7 over 2. Again, let's check our work. Let's plug in 7 over 2 for the x's. 7 over 2 minus 1 will give us 5 over 2. Right? So then this, again, if you put in the calculator or you use the exponent power, the exponent rule, right, this will give us 32. So 32 equals to 32. So I know that's my solution. Now let's solve in logarithmic equations. I believe I need 2 more examples, guys. I know it's already past time, or it's already time, but let me finish the next 2 examples. So to solve logarithmic exponential equations, we need to know some of the properties here. Okay, also for the ln. Example. Hey guys, recall that we did this one, guys. Remember the same base was 3. This was 3 squared. It was 3 cubed. Remember that from I think 2 slides ago. But we can work it another way. Remember that was my answer, right? So solve by using the power property of natural logarithms. So we're going to take the ln of both sides. We have to bring down the x, so we take the ln of both sides, which is this one here, the ln. So by rule, right, the exponent goes to the front like it did over here. Use the power property, which is this one here. The exponent goes to the front, so the x goes to the front. Then we divide both sides by the ln of 9. Use the calculator. And there's my answer. X equals to 1.5 or 3 over 2. Okay, now guys, please be real careful, guys. Very important. The ln of 9, or I mean the ln of something, of a number, it's an actual value. You cannot say these cancel here. The ln's, you cannot say that, because the ln with a number is an actual value. It cannot be, you cannot separate them. So please be careful with those. Now let's do another example here. This is using another rule. Example 26, if 5 to the x equals 8. So again, this is a rule that we're applying, which is the power rule. So we're going to take, right? So when you start, these cannot be used by using the same base. You cannot. So you're forced to use the ln. The exponent goes to the front. Then we divide both sides by the ln of 5. We use the calculator. So there's my solution. Most of the times, they're going to want you to round it off to 4 places. Okay, so this approximates my solution. So let's check. To check it, I'm going to plug in 1.2920 for the x. You see, guys, it gives me something very, very close to 8. Because here, guys, they rounded off to 4 places, so it's going to be a little bit short. But this is my, right, this is real close to 8, so I know that's my solution. So this is, if you have log of base A, u equals to log of base A of v, then the u must equal to v. For example, here. This is example 27. I believe I need one more example, or this is the last one. I don't know. Okay, I'm not sure, but I'll be done in about another 2 or 3 minutes. So before we work this out, right, we have to condense the log on the right side, because it means if you have a single log on the left side and a single log on the right side with the same base, then the u must equal to v. In this case, the right side, I need to condense it. Okay. So I'm going to use the quotient property, right? Because if it's minus, it's going to be the quotient. Now it's condensed. Now, right, we have the same log on both sides, and the base, right, there's no base, so I know it's base 10. So now we can apply the rule. So by applying the rule here, right, so again, we have the same log with the same.
Sir Zassi,
Yes.
Suzette has a question.
Okay. What's up, Suzette? What's your question, Suzette?
You can turn on your mic if you like.
Hi, thank you so much. Hi, Professor Sassi. I apologize. Thank you so much for your instruction. I'm really catching on to it. I apologize for clicking on my hand raised. Sorry about that.
Don't
Thank you.
This is what we're here for.
Okay, thank you so much. I love your layout, how you're showing us step by step. Thank you.
Oh, you're welcome. Okay, so what was your question?
I apologize. I don't have a question. I accidentally raised my hand.
Okay.
Sorry about that.
That's okay, but to me, my job is to make you understand the material, and thank you for those nice words, because I do take time with my PowerPoints and I try to bring them to life. Okay, but thank you. Okay, now so let me continue here. So here, guys, I'm going to use here you can solve it by using the cross product, right? I mean, or by multiplying both sides by x minus 1. Here, guys, what I'm going to do here, I'm going to cross multiply. So this is the same thing as x over 1. So I'm going to multiply x times x minus 1 and 1 times x plus 3. So this is what I get. Now here, guys, I'm going to distribute. So this becomes x squared minus x. Right now, since we have something squared, the terms on the right side must go to the left side. So I'm going to subtract x and minus 3 to both sides. Right, because I have to let it equal to 0 so I can factor. So we notice on the right side, it's going to equal to 0 because x minus x is 0 and 3 minus 3 is 0. On the left side, we have x squared. Negative x minus x will give us negative 2x and then minus 3. So this is what we got on the left side. Now we factor, right? And good thing that we did the PowerPoint on factoring. This is called the easy factoring, right? Because we have 3 terms, and there's the coefficient here is 1. So to factor right, this means the signs are going to be different. This sign comes down. If we get the factors of 3, it's going to be 1 and 3. And when we subtract them, that's where we get the 2 from. So these are the factor form. Now I'm going to apply. It's called I'm going to set the binomial equal to 0. So this is called the zero property theorem, where I'm going to set both factors equal to 0. So on the x minus 3 equals 0, I'm going to get x equals to 3. What I did here, I'm going to get x equals to 3. So for x, I'm going to get x equals to 3 and x equals to negative 1. Now let's check our work on the next PowerPoint here. So I'm going to plug in. First, guys, I'm going to plug in negative 1 for every x. Right, negative 1 goes there for the x, and also here and here. Hey guys, the logs cannot be equal, cannot be negative. That's why we know that this is no solution, not defined. So in other words, negative 1 is not an answer to these, because negative 1 is not defined, is no solution. Now let's plug in the 3. I'm going to plug in the 3 for the x there, and also here the x plus 3, also here, and also here, guys. So the 3 goes for all the x's. So this will be log of 3, right? This will be 6 minus log of 2. If you use a calculator, guys, right? Then this will be the answer. But you can get these without using the calculator. Let me show you how. Okay, now, if you notice here, guys, right? I'm going to condense this one here on the right side, because you have the same base, right? They're both base 10. So I'm going to use this as a quotient. So this becomes division. We're using quotient property. So, right, so 6 divided by 2. 6 divided by 2 is 3, correct? So you see they're both the same. So I know that was my solution. So the only answer for this one, for this problem, was 3, x equals to 3. I believe one more example here. Now, this is another rule that we're going to be using. If a and u are positive real numbers with a cannot equal to 1, then if you have a raised to the power of log of base a of u is equal to u. In other words, a log of a is equal to 1, and the u will just bring it down. So in other words, this is what I'm going to be doing here. Okay, for example, number 28. I have to get rid of the log of base 3. So I'm going to raise both sides, right? I'm going to raise both sides. I'm going to use 3, right? So this log here is going to be a 3 here on both sides, because this is what I'm trying to do. Let the expressions on both sides, right? These expressions on both sides be the exponent. And the base is what I'm going to be using, right? This base here goes on the left side and also on the right side. Again, if it was a 4, if it was log of base 4, then this would have been a 4 here. If this was a log of base 5, then we will use 5. Because this is 3, right? Because we want to apply the rule here on top. That's why the bases must match. The base from the exponent and the base from the log must match. Now, by applying the rule here, guys, 3 raised to a log of base 3, this is equal to 1, or this cancels. So we bring down the 6x minus 2. And 3 squared is equal to 9. Okay, now we solve for x. We add 2 to both sides. We divide by 6. So x equals to 11 over 6. Again, we can check our work. So let's check it. Right, so the answer was 11 over 6. So I'm going to plug it in for the x. 6 times 11 over 6, right? The 6 cancel. 6 divided by 6 is 6. So we get log of base 3 of 11 minus 2, which will give us 9. And if you put this in the calculator, it's going to give you 2. There's different ways to find the answer here, guys. But for now, we'll just put it in the calculator by applying the change of base. So this is 2 equals to 2. So I know this is my answer. And here, guys, you can apply the change of base or convert 9 into 3 squared. And then the 2 goes to the front. And log of base 3 of 3 is equal to 1. So there's like 3 ways to get the answer here. But the best way for now is to plug into the calculator by using the change of base. And thank God that we're done. Let me go back to the screen. And I apologize for taking a little bit longer, but I really thought that it was important for me to cover every slide on the PowerPoint, because this is a mini master for the 1324, and there's a lot of material that's being covered every week. And what I chose for this PowerPoint was a material that I thought as an instructor was the most important topics for this week.
Absolutely, Mr. Zassi. I believe so too. Very important topics, especially in math, considering they build on each other. At
Yes,
this
ma'am.
time, do we have any questions? All right, so if there are no questions, I'd like to thank you, Mr. Zassi, for presenting for us today. You do a wonderful
welcome.
job, like always. I would like to invite everyone to next week's sessions. For Math 1314, we're going to be going over exponential and logarithmic functions, as well as their properties. For Math 1324, we'll be diving into simple and compound interest annuities and system of equations. Once again, thank you, Mr. Zassi. Thank you, everyone, for coming today, and I hope you have a wonderful weekend.
Thank you, Patricia. Bye.